I have this example. The normal healing of wounds can be modeled by an exponential function. A naught represents the original area of the wound. A equals the area of wound, and the function A equals A naught e to negative 0.35 n. Describes an area of a wound after n days following an injury when no infection is present to retard the healing. So what we're saying is suppose the wound initially had an area of 100 square millimeters. So that's saying that A naught is 100. So A is going to be 100 e to negative 0.35 n. So I want to know how many days would it be 1/2 its original size. So if it's going to be 1/2, 1/2 would be 50, right? So when is 50? 100 e to negative 0.35 n. So I want to divide by 100, and that tells me 1/2 is e to negative 0.35 n, and now I'm going to use my definition of a log, which tells me that the natural log of 1/2 equals negative 0.35 n. I can divide by negative 0.35, and I find that n is 1.98 days. Now notice when I wanted 1/2, I don't really have to put that 100 in because when I do 50 divided by 100, it's 1/2. So if I want to know 10% of its original size, that's 0.1, right? So 0.1 equals e to the negative 0.35 n, or the natural log of 0.1 equals negative 0.35 n. Divide by negative 0.35, and you get n is 6.58 days. Now you're wondering maybe if I have this negative here, how come everything came out positive? Well, remember what the log looks like, right? When I am less than 1, it's a negative number. So when it's a fraction, it's a negative number. So when my argument is a fraction, less than 1, it's a negative number. So I have a negative divided by a negative, and that's a positive.